Alright, acid bases salts. First thing is, what is an acid?
Um, it's something which is high concentration.
It can be high concentration of salt also. If you add too much of salt in water, then that is going to give you a concentrated salt solution, whatever the salt may be. Okay.
Uh, yeah.
In your lower classes, you have done some of the properties of acids, and on the basis of that, you had defined acids. Acid is any substance that is sour in taste and it turns blue litmus red.
Yeah.
Okay, but this definition will not be accepted in class 10. As per definition of acids, any substance that is dissolved in water is going to form hydrogen ions.
Yeah.
Okay, but still this hydrogen ions is also going to be an incorrect term. This hydrogen ions, which is going to be H plus, it will combine with water, that is going to produce H3O plus. Okay, this is what is known as hydronium ion.
Oh,
Okay,
yeah.
how the formation of hydronium ion is taking place. Okay, for that you can just go through my bonding chapter video, that is formation of hydronium ion. It is there in my channel.
Okay.
Right.
Yeah.
Okay, so basically here these H plus which is there, this H plus we can also call it a proton.
Yeah.
Okay, now you know hydrogen atom,
There's one proton,
there
one electron.
there is one proton and here there is one electron in the
Electron.
outermost orbit. This is a single hydrogen atom.
Hmm.
But suppose if this electron is gone,
One
okay,
proton.
then in the nucleus there is only one proton remaining.
Yeah.
Okay, this proton is nothing but a hydrogen ion which
Yeah.
combines with water in its aqueous solution and it produces H3O plus, that is going to be a hydronium
Hydronium. Yeah.
ion. Okay, so this is the
Yeah.
definition of an acid. So on the basis of this definition, okay, suppose if I'm having an acid, say like HCl, okay, now this HCl can be of two types. This HCl, either it is hydrogen chloride gas.
Hydrochloric acid. Yeah.
If this hydrogen chloride gas is dissolved in water, it's highly soluble. Hydrogen chloride gas is highly soluble in water. Okay, when it is dissolved in water, it is going to form aqueous
Hydro.
solution of HCl, which is going to be hydrochloric acid.
Yeah.
Now, when this HCl is in the form of a gas, then it does not exhibit any acidic properties. The reason for that is here there is no water when it is pure hydrogen chloride gas. So at that time it does not show any acidic properties. It means that when it is hydrogen chloride gas, it's not going to turn blue litmus paper red. Only when you dissolve it in water, these HCl which is there, it is going to separate out. We call this process as ionization.
Yeah.
Afterwards, I'm going to come to the difference between dissociation and ionization also. Okay, this is going to produce H plus and
Cl
Cl minus.
minus.
All right, this H plus in presence of water is going to become
H3O.
H3O
Oh,
plus. This is
plus.
hydronium ion which is responsible for acidic property of
Yeah.
hydrochloric
Acid.
acid. While pure HCl gas, that is hydrogen chloride gas, which is there, it is not going to exhibit acidic properties because in that case there are no H plus or Cl minus
Yeah.
ions.
I. So,
Okay, I'll just come to that difference between dissociation and ionization as well. Okay, you have done what are called covalent compounds
yeah.
and what are
That's
ionic compounds.
covalent is sharing of electrons and ionic is giving.
Correct. Covalent compounds are formed by sharing of electrons and ionic compounds are formed by transfer of electrons, that is give and take of electrons.
Yeah.
All right, the simplest example of a polar covalent compound is HCl. Okay, and the simplest example of ionic compound that we are going to take over here is
NaCl.
sodium chloride. Okay, which already exists in the form of Na plus
Uh,
and Cl
Cl
minus. That is the
minus.
ionic form, right? Okay, now what do you understand by this polar covalent compounds?
One like hydrogen, there is one which is heavier than fluorine.
No, 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 no. That's not the case. Okay, you see here there is sharing of electrons,
Yeah,
but this sharing is not equal. It's unequal. Can you tell me what is the electronic configuration of hydrogen?
one.
Okay,
Yeah,
I'll just take it to the next page. The electronic configuration of hydrogen is 1. What's the electronic configuration of Cl? Proton
7.
number is 17.
Well, big 2, 7.
Okay.
Yeah,
Now here there is shortage of one electron to make octet state.
yeah.
Here while hydrogen which is there, it's already having one electron. In the first orbit maximum you can have two electrons so that it can complete its
Okay. Question.
duplet state. Duplet state means having two electrons in the first and the outermost orbit. Okay. So if it shares this one electron, how this bonding is going to take place? I'm just going to show the outermost orbit of chlorine. Here there are 7 electrons.
Yeah,
Okay. While hydrogen which is there, it is having only
1.
one electron. When this sharing is going to take place, both electrons will be shared. Okay, so now after formation of HCl has taken place, now we can show the bonding in this way.
And cross and 0.
Correct?
Yeah,
This is your HCl molecule. In terms of structure, I can show it like this. This one line is called the single bond. It means there is a pair of electron that is being shared, which is shown over here.
yeah.
Okay, this is your single covalent bond.
Yeah.
But remember here chlorine is having 7 electrons in its outermost orbit. So it's
Yeah.
very close to 8 electrons. So chlorine has greater ability to pull this shared pair of electrons than hydrogen. Okay, I'm repeating the last statement. Chlorine is having greater ability to pull this shared pair of electrons compared to
Hydrogen.
hydrogen.
Yeah.
Due to this reason, what happens? Okay, here the electron pair is more shifted towards Cl. So this is going to develop a very small negative charge, which I'm going to write like this. It is delta negative. That is a very small negative charge developed towards chlorine because the electron pair is unequally
Yeah.
shared. So the electron pair is pulled more towards Cl, that develops a small negative charge, which I'm going to write delta negative
Fine.
charge. Similarly, your hydrogen, because the electron pair is more towards Cl, this is going to develop a small
Positive charge.
positive charge, which I'm going to write this as delta
Positive.
positive charge. Now, because here small negative and positive charges are developed, this kind of a bond is called a polar bond. A polar bond is such a bond where the sharing of electrons is not equal. Okay, because obviously here the sharing of electrons is there, so we call this bond as a polar covalent
Covalent bond.
bond. Whenever you dissolve such polar covalent substances in water, what is going to happen is chlorine will take away both of these electrons. So Cl is going to take away that electron of hydrogen. Because that electron of hydrogen is with chlorine, it is going to develop a complete negative charge, that is going to be chloride ion, which is going to be Cl minus.
Yeah.
Similarly, here hydrogen has lost away its electron after dissolving in water. Obviously, that's the case. So therefore, hydrogen is going to develop the positive charge, which is going to be written as H plus. So HCl, after being dissolved in water, it forms H plus ions and Cl minus
Iron.
ions. Now here originally when HCl was over here, it was not in the ionic form. But after you dissolve it in water, there is formation of ions. This process is known as ionization. Okay. So ionization is what? The process of formation of ions which originally or initially did not exist in the ionic state. Before it was HCl molecule, although it was polar covalent, but there were no water molecules. After it is dissolved in water, completely that chlorine atom takes away the electron, forming Cl minus, that is chloride ion, and H plus ions. Okay, so this is the process of formation of ions. Therefore, this is going to be the process of ionization. I'm just coming back to NaCl. Okay, NaCl originally what is there? Na, the electronic configuration is 281. Chlorine, the electronic configuration is 287. When Na and chlorine combine together, completely that electron is, in the beginning only the electron is transferred from Na to Cl. This makes Na plus ions,
NCL,
Cl minus ions. These both are attracted with a very strong force of attraction. What is it called?
Um,
The force of attraction existing between ions in an ionic compound. This force of attraction between the positive and negative charges, that is oppositely charged ions, is called as electrostatic force of attraction. Okay, this term is very important when you are doing that bonding process. Okay, so this is an ionic bond. It means here already the ions are present. Now this NaCl, what is it basically?
it's sodium, salt,
Yeah, obviously it's common salt that we eat every day. Okay, that is sodium
chloride.
chloride. Now this sodium chloride is a solid ionic compound in which these ions are bonded together very strongly.
Yeah.
It means they will be poor conductors of electricity, although you know that ionic compounds are good conductor of electricity, but that's only in the molten state. Molten state means what?
It's very heat, like lava type.
Yes. Yes. When you heat it, it gets converted from solid state to
Like,
liquid state. Okay. The melting point of sodium chloride is almost 900 degrees Celsius. So it's having very high melting point. So if you take it to such a high temperature, then from solid sodium chloride, you are going to get liquid sodium chloride. Remember, it is not aqueous solution. You have not dissolved it in water.
yeah.
So in these conditions, these Na plus and Cl minus, they both can get separated and then they will be free to move. Under such conditions, they will be good conductors of
Heat.
electricity.
Oh, yeah.
Okay, because here charged particles will be obtained. Initially, when it is in the solid state, these Na plus and Cl minus, both of them are together. Although ions
Yeah.
are there, but they both are bonded together very strongly because of this force of attraction. That is electrostatic force of attraction. So under these conditions, when it is in the solid state, it won't be able to conduct electricity. Only when you
Yeah.
take it to the molten state, or you do another thing, you dissolve it in water. You know, common salt is highly soluble in water. When you dissolve it in water, again Na plus and Cl minus, both of them get separated out because of
Yeah.
presence of
Water.
water molecules. Now here originally ions were already present, Na plus and Cl minus. What you are doing after dissolving it in water, you are simply just separating it out. This process is called as dissociation. For ionization, what example I had considered? It was HCl. Originally here
Yeah.
ions are not present. It's a covalent compound, it's a polar covalent compound. So such compounds will undergo ionization. That is formation of ions, and dissociation is what?
Remove.
Already
Like
the ions are
separation.
present, it's just separation.
Yeah.
Either you dissolve it in water or you convert it to
Liquid.
molten state.
Yeah.
That is, you heat it to its melting
Yeah.
point.
Nice.
Okay, so this was the difference between dissociation and ionization.
Ionization.
We'll just come back to the topic of acid bases.
Yeah.
Okay, now HCl we have done. When it is in the gaseous state, it's a poor conductor of electricity because here there are no ions present. Only after you dissolve it in water, it forms H plus ions and
Cl
Cl minus ions. This H plus will combine with water, is going to form
H3
H3O plus. This is hydronium
hydronium ion.
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 Okay, later I'll just send you the link, or you can just go through my channel to see what is formation of hydronium
Hydronium.
ion. That is the part of bonding chapter. Okay, now here HCl is one of the substances that is forming hydronium ion. So basically it is such a substance which is a proton donor. I can
Okay.
just combine both of these equations and write like this: HCl plus H2O. Out of
It
this,
has
from here, H plus will come over here. That's going to become H3O plus. That's hydronium ion. What is the other part that is remaining? Cl minus. That is chloride. And basically, HCl over here
ion.
is what it is doing. It is donating a proton. It is giving H plus. Okay, which is going to form hydronium ion.
H3O and yeah.
Okay.
Yeah.
Similarly, there will be other substances like say HNO3. What
Yeah.
substance is this?
Nitrate.
Okay, this is nitric acid.
Yeah.
So from here, this H will go over here in the form of H plus.
Yeah.
What is that going to become?
H3O hydronium ion.
Hydronium ion. What is the remaining part that is left?
And NO3 nitrate.
NO3 with single
Nat.
negative charge. Okay, this is
Yeah.
nitrate ion.
Yeah.
So any substance that produces hydronium ion when dissolved in water is an acid, or any substance that donates a proton or which is a proton donor is defined as an acid.
Proton.
Okay. Yes, a
Yeah.
proton donor or that forms hydronium ion when dissolved in water.
Nice. Okay.
I'm just going to consider one more example over here. What substance is this?
Sulfuric acid.
Okay, this is sulfuric acid.
So that will become H4O.
No. Okay. Now here one sulfuric
No, it will
acid
become
molecule.
H3O and then
Yeah, one sulfuric acid molecule can donate 2 protons. Okay, so it is going to become 2H3O plus, and the other part that is remaining over here is
SO4.
SO4 2 minus, that is sulfate ion. Obviously here there are 2H3O plus, so that is going to combine
2H2.
with 2 water molecules. So it is going to form 2 hydronium ions per molecule of sulfuric acid, and this remaining part obviously is sulfate
Sulfate. Sulfate.
ion.
Ion.
Okay,
Yeah.
these three of them I told you earlier also, they come from minerals, these three acids, so we call them mineral acids.
Yeah.
And remember, mineral acids are strong acids. Afterwards, I'm going to come to the definition of strong acids and weak acids, and what is a dilute acid and what is a concentrated acid. We'll just understand the difference between all of these substances. Okay,
Yeah.
these three acids, HCl, HNO3, and H2SO4, okay, they come from minerals, so therefore we call them mineral acids, and these three mineral acids are strong acids. Okay, just one sec. We come to what will be weak acids. First, I'll just take the examples. Okay, acetic acid. The formula of acetic acid is CH3COOH. In organic chemistry, later we'll do it. It's called as ethanoic acid. They'll combine with water. There is only one H which can form this hydronium ion.
Yeah.
So that is going to become H3O plus. And
Yes.
the remaining part is going to be
CH3CO. CO.
CH3COO, single negative ion. This is known as ethanoate ion. or acetate ion. Okay, now this is a weak acid. Now what do you understand between what is a strong acid and what is a weak acid? See, here we had considered HCl, HNO3 and H2SO4. These substances, when you dissolve them in water,
They are mineral acid. Yes.
yeah, obviously they are mineral acids and they are strong acids. But what do you understand by the strong acids? When suppose if I'm having 100 molecules of HCl, okay, when you dissolve it in water, 92% of them will split up as H plus and Cl minus, while 8 of them which are there out of 100 will remain as HCl together only.
Okay.
It means the percentage of separation that is taking place is very high. Such substance is going to be a strong acid. Such acid is going to be a strong acid. Whichever substance is going to separate out to a very large extent, that's going to be a
Strong
strong acid.
acid.
Even HNO3 and H2SO4, they separate out almost to an extent of 90%. Therefore, these are going to be strong acids. It means they are going to form very large number of hydronium ions and whatever the negative ion that is present.
Yeah.
Okay, depending upon what the acid is. But here you see, in case of acetic acid, that is ethanoic acid, the percentage of separation, that is the formation of hydronium ion, is almost to the extent of
5%.
5%. Means most of them, 95% of them are going to remain as whole molecule only. They are not going to separate out.
Okay.
While only 5% of them are going to give you all this. So such substance, such acid is going to be a weak acid. Remember, there is a difference between strong acid, weak acid, and concentrated acid and dilute acid. Now I'll
Okay.
come to that part. What is a concentrated acid and what is a dilute acid?
Concentrated without water. Diluted with water. No?
Don't say without water. Concentrated acid, when you say very
Anhydrous.
less amount of water is there. Okay, no, anhydrous, if you say, it means it becomes pure totally. There is no water at all. That's not going to behave. That substance is not going to behave like an acid at all.
Okay.
Concentrated acid means almost you can say a very strong acid. Sorry, a concentrated acid, when you say, in the sense we say there is very less water present. Okay, suppose if I say that I'm having 60% concentrated H2SO4. When I say 60% concentrated H2SO4, it means 60% of H2SO4 is there and 40% what is present?
Water.
Water is present. This is the meaning of a concentrated acid. When I say, suppose they are dilute acid, suppose if I say 2% concentrated H2SO4,
Oh.
I
Very
mean to say that 2% of H2SO4 is there and 98% is
water.
water. So that's going to be what or dilute acid is.
Diluted.
But remember, this acid is also a strong acid. Why it is a strong acid? Because it is a mineral acid.
Oh.
So the separation that is going to take place, that is going to be a very large extent. Why? Because it is a strong acid.
So all mineral acids are dilute acids.
No, no, not necessary. We can have a concentrated acid which is a strong acid as well. Okay. So if large concentrated acid basically means mineral acid, HCl, H2SO4 and HNO3.
Oh.
And when I say strong, when I say concentrated acid, it means a large amount of water, a less amount of water is present. I can have a concentrated acid of acetic acid also. I can have very large amount of acid present and very less amount of plus water present in it. Although this acid is a concentrated acid, but still it's going to be a weak acid. Why it's a weak acid? Because it's not a mineral acid. It's an organic acid.
Yeah.
You got all the
But
points clear? Yeah, tell me.
You can change the concentration of any acid, huh?
Yes, obviously you can add more water, you can remove water from it, and you can change the concentration of the acid.
So that means one acid can be both concentrated and dilute.
No, how can you have concentrated as well as dilute? You just have to
50-50.
see the proportion of water present in it. If large amount of water is present in it, then it's a dilute acid. If less amount of water is present in it, then it's a concentrated acid. But you
What
can
if
have a dilute acid which is a strong acid, as I have considered this example. See, this is a dilute acid because here large amount of water is present. 98% water is present over here.
yeah.
Still, it is a strong acid. Why? Because it is a mineral acid.
What if there's 50% acid and 50% water?
Then you can say it's a normally or medium concentrated acid.
Okay.
Okay.
Yeah.
So that was about strong acid, weak acid, concentrated acids, dilute acids. Out of this, we have considered dissociation reactions of acids.
And
Okay.
ionization.
Yeah. Okay. So this was definition of acids and bases. Okay. Bases we have to do in terms of proton transfer limited to aqueous solution.
Solution.
Now we are going to go to the next part, that is basis. Now as we have defined an acid which is a proton donor,
Yeah.
a base is a substance which is simply a proton acceptor. Okay, that's the definition of a base.
Yes.
Okay, let's consider a few examples. I'm going to consider some oxides as well as hydroxides of metals. Okay, I'll take first example, say
Hydroxide, oxide.
okay. Yes, can you predict what are going to be the products?
First one will be NaCl plus H2O.
Okay,
Second one is KNO3 plus H2O. Third one is CuSO4 plus H2O. And NgSO4 plus H2O. H2O, sorry.
okay.
Yeah.
Now here in each one of these cases, this is accepting a proton. Obviously, in this case, with H with OH, what does it form? It produces
H2O.
H2O. Okay, if I just
Yeah.
write down the reaction like this, say NaOH, this part becomes H2O,
That's the NaCl.
that part becomes NaCl. Okay, so here, can you tell me what this reaction is known as?
Um, I forgot. Double displacement. Yeah.
Uh, of course, it's a type of double displacement reaction, but in specific, this reaction is a reaction in which an acid and a base that is going to combine to produce a salt and water. What is this reaction known as? This is known as,
Neutral. Oh, oh yeah.
okay, any reaction in which an acid and a base combines together to produce salt and water. This reaction is called
Neutralized.
neutralization reaction.
Yeah.
Now here you can see this is an oxide of a metal. Copper is the metal. Copper oxide is the oxide of this metal. Here it accepts the proton to produce salt and water. Of course, this reaction is also neutralization, but in all of these cases, okay, is going to be a proton acceptor. That is going to be the definition of a base. Okay. Now, what are these bases? Either they will be hydroxides, as you can see in these first two cases, or they can be oxides of metals. All right.
Yeah.
These both oxides of metals, they are insoluble in water. These both hydroxides, okay, they are soluble in water.
Aren't they already water?
No, not necessarily. You can have solid sodium hydroxide also, where there is no water molecule present. Correct?
Oh,
But because these are
yeah.
soluble in water, we give a special name to these bases. These bases are known as alkalis. These are
Yeah.
bases, copper oxide and magnesium oxide. They are, although they are bases, because with acid they produce salt and water. But because they are insoluble in water, we do not call them alkalis. Only those bases which are soluble in water, we will call them
Okay.
alkalis. Okay, so alkalis are simply water soluble bases, and bases are those which
Yeah.
will, with an acid, produce salt plus water.
Water.
Okay, so
Yeah.
another point that we have added up over here. Okay, bases are what? Either oxides or hydroxides of metals.
Metal.
Okay,
Yeah.
even these oxides. Okay, suppose if I am considering here oxide of, say, sodium or potassium. Let me take here, I am taking an example of, say, okay, this is sodium oxide, this is potassium
Potassium
oxide.
oxide.
When you dissolve this in water, can you predict what the products will be?
Na2O plus H2O and K2O plus H2O.
No, it will be simply NaOH
No.
and KOH. Balancing is
Oh, yeah.
quite simple. Okay, so these are
Yeah.
oxides of metals. They dissolve in water. They produce
From
alkalis.
hydroxide.
Even NaOH itself or even KOH itself, these are solid substances. Okay, you can dissolve them in water. They are soluble in water. Okay,
Then what will they form?
which one? No, this will be simply soluble in water. It will be forming a solution of sodium hydroxide, aqueous solution of sodium hydroxide.
Oh,
I'll just show you some pictures also.
yeah.
You can see in this picture. Okay, this is solid sodium hydroxide.
Yeah.
And how is that solid sodium hydroxide obtained?
By adding water to salt.
Correct.
No.
If you are
Sugar.
adding limited amount of water to it, then you are going to get this solid sodium hydroxide.
Yeah.
Okay. But this solid sodium hydroxide also, you can dissolve it in water and you can get its solution. Correct.
Okay. Yeah.
All right. So
Sodium
this is
oxide is also solid.
that is also solid. Okay.
Okay.
Sodium oxide is also solid. You can mix it with water and you can get even solid sodium hydroxide also. If you add more water to it, then you are going to get a solution that is aqueous solution of sodium hydroxide. Correct. So these are basically oxides or hydroxides of metals. Okay, that is bases are either oxides or hydroxides of metals. If they are soluble in water, then they will be forming an alkali. If they are insoluble in water, then they will be simply bases but not alkalis. Okay, so
Yeah.
all alkalis will be bases, but
But
all
these are
bases
not.
may not be alkalis. Clear?
Yeah.
Okay. The next part that we are doing over here, oxides of non-metals. I'm taking a few non-metals like, okay,
Yeah.
carbon, nitrogen, sulfur, phosphorus.
Yes, yes.
The oxide, one of the oxides of carbon I'm taking, that's
Yeah.
carbon dioxide.
And
Okay,
that's what we have. Yeah.
all right.
Oh yeah. Yeah.
I've taken the examples of oxides of non-metals.
Non-metal.
Okay, some of the examples of oxides of non-metals I have taken. All
Yeah.
these oxides of non-metal, they will be forming acidic oxides.
Also, all metal oxides are base and all non-metal oxides are acids.
Most, don't say all.
Oh,
Okay, most of
yeah.
the non-metal oxides will form acidic oxides, and most of the metal oxides will form basic oxides. Now,
Oxides.
what are these acidic oxides? Any acidic oxide, when you dissolve or mix it with water, it forms an acid. Now, let's take all of these examples. Okay, the first
Yeah.
example of acidic oxide that we have considered is carbon dioxide. It combines with
Yes,
water.
it's true.
This is
Carbonic acid.
carbonic acid. This is nothing but your soda water.
Yeah.
Okay, the fizzy drinks which are there, the gas that is coming out in the form of fizz is carbon dioxide. Okay, the second one
Yeah.
that we are taking over here. Okay, I'm not writing over here the reaction because that will come in Oswald's process. There are steps for this. This is going to form the acid which is going to be,
Azomic.
okay,
Nitric.
nitric acid, that is. Okay, sulfur dioxide. This is sulfurous acid.
Yeah. Sulfuric.
This is phosphoric acid.
Why H3?
That's the formula of phosphoric acid. Okay, you can obviously balance this equation.
Okay. Yeah.
Okay, so you have seen over here that non-metallic oxides, they produce acidic oxides, and acidic oxide is such a substance which when dissolved in water will produce an
Acid.
acid. Okay, so that is one of the properties of acidic
Okay.
acids. Then all right, these all reactions are there. Okay, that is reactions of acids with metals, bases, carbonates, and even hydrogen carbonates or bicarbonates also we will be considering. And obviously the effect of litmus that we have just done in today's beginning part. What is the litmus color change that any acid is going to show?
Blue to red.
Yes. Okay.
Yes.
Acid will be the substance in terms of litmus. If I am considering the litmus color change that it is going to show is going to be blue to red.
Red.
And alkali,
To red to
that's a
blue.
water soluble base, is going to show red
Red
to
to blue.
blue. Other indicators also we are going to consider. Okay. What is an indicator?
The
It is simply a
which
substance which
shows you
is,
it's an
yes, which is
acid.
going to show you whether the
Changes
substance,
color.
yeah, with the help of color change, it is going to show whether the medium is an acidic medium or it's an alkaline medium. Another indicator
But
that I'm going to consider example over here, that is of phenolphthalein.
how do you know if it's a base then?
In the sense,
If it's not, if it's a base which is not soluble in water,
yeah,
how do you like test it?
in that
Litmus
case,
paper
we will
there
have
is
to,
no.
we can use an acid, and if you get salt and water, then obviously that
Oh,
substance is going to be a base. Okay. So here now we are
yeah.
going to see the color changes for phenolphthalein. Okay. Phenolphthalein in acidic medium, it's colorless, and in an alkaline medium, it becomes pink in color.
Okay.
Okay. And if it is alkaline phenolphthalein, in acidic medium, it will turn colorless.
Okay.
Okay. Later on some of the YouTube videos, I'm going to show this color changes of litmus as well as of phenolphthalein. Okay. So those things were about color changes. I'm going to consider now here the reactions of metals with acids. Okay. So that's the next part. I'm going to consider here the entire activity series of metals. So we will have to consider even the displacement of hydrogen from a particular
Fine.
metal. Yes, can you give me the name of the activity series of metals?
Um,
You have done the activity series, right?
which reacts more, right? The most reactive.
Yeah, you'll have to learn or remember this in this particular series. Okay, the most reactive metal will be on the top and the least reactive metal will be at the bottom.
But
And you are supposed to
potassium is the
know,
first, right?
yes, okay. I'm just going to give you that how you are supposed to remember this entire activity series. Okay, you remember this keyword PSC, maxital. Again, leave a gap over here. Could make silver, platinum, gold. What is the keyword that I have given you? PSC,
PSC, maximal,
MACZITL, maxital, could make silver, platinum,
Cl, Sg,
gold.
yeah.
This is potassium,
Sodium, carbon.
sodium, calcium.
Calcium will be Ca, huh?
Yeah, okay. Magnesium. No, but in order to remember this conveniently, that's why I have
Okay.
written that PSC, maxital, could make silver, platinum, gold.
Yeah.
Okay, this is your magnesium. Aluminium. I'm adding over here carbon as well. Why we are adding here in between carbon? That will be useful in metallurgy when we study extraction of metals. Then Z will be zinc. I is iron, that is Fe. T is tin, that is Sn. Okay, L is lead, that is Pb. In between here, hydrogen is also coming in activity series. So all these metals which are above hydrogen, they are more reactive than hydrogen. And all the
Yeah.
metals which are below hydrogen, these metals are less reactive than hydrogen. Cud is copper, that is Cu. Make is mercury, that is Hg. Silver is Ag. Platinum is Pt. And gold
Okay.
is Au. Okay.
What's the between C and M? Then
What's the?
what's the between calcium and magnesium?
There is nothing between calcium and magnesium. Only in order to remember it uh, in a convenient way, I have just written it like this: PSC, Maxital could make silver, gold, silver, platinum,
Oh,
gold. Okay. Now all the metals that are above hydrogen in the activity series, it means from the dilute acids they will be able to displace hydrogen. Okay. But of course, the reaction,
yeah.
these three metals which are there, they are highly reactive. Their reaction with acids are going to be explosive. These three metals which are on the top, they are considered to be highly reactive metals. These are all moderately reactive metals. Of course, as we go down in the activity series, their reactivity is decreasing. And these metals are going to be very less reactive metals. Okay, this activity series of metals you should know by heart because it will be used at many places. The first place where we are right now going to use it is its reaction with hydrogen. Okay, that is, sorry, the reaction with acids. So these all metals which are on the top of the activity series, they will be able to displace the the metals will be able to displace hydrogen from their acids. So I'm going to first consider the first three metals.
Potassium, calcium.
These reactions are going to be explosive, so these reactions cannot be carried out in laboratory, ordinary school laboratory. You can choose any acid. Okay.
Yeah. Explosive, you mean like whole building explosive or just one room?
No, but it will be quite dangerous. The entire laboratory can get destroyed.
Oh,
Okay. So now you can predict the products.
KCl plus hydrogen gas, Na, NaNO3 plus hydrogen gas, CaSO4 plus hydrogen.
Okay. So you can see these dilute acids from metals, they will displace hydrogen and that's going to produce, in each case, hydrogen gas will be produced. Of
Okay.
course, you can do the balancing of equation, which is going to be very simple in all of these cases. Then
Yeah.
those metals which are going to be moderately reactive, their reaction is going to be a bit slower than these. As you go down in the activity series, their reactivity will keep on decreasing. Okay. So the next metal, maxital. So Ma, Mg, then Al, then Zn. I'm not going to
Okay.
consider over here carbon. Okay, because that's we are going to use it only for metallurgical purposes. Okay, even the other metals which are much lower. Okay, that is tin, Sn, and Pb. These both metals also their reactivity is going to be very very less. Okay, so we are going to ignore those metals. Then I'm just going to add any acid to this. Suppose here I'm considering. Yeah, you can.
N2SO4 plus hydrogen and AlCl plus hydrogen.
AlCl3.
Zn, ZnCl plus sorry, ZnCl2 and Fe2SO4 plus hydrogen.
FeSO4. Okay, now here in most of the cases I have ignored your nitric acid because the reaction of nitric acid is a bit typical. It's different than from our standard mineral acids of HCl and H2SO4. Okay, that we will do when we study the topic of nitrogen compounds, that is of nitric acid. Okay, ammonia and those compounds which are there, at that time we will do that. Okay, so now these reactions are also quite obvious and easy to balance, so I'm just not going to go to the balancing part of these equations. Here you should remember that as you are coming down, these metals will react with less intensity with these acids, and the reaction is going to become slower and slower. Of course, in each case we are going to get hydrogen gas. Okay, now as we are coming to the metals which are below hydrogen, copper,
Yeah.
mercury, silver, platinum and gold, these metals are not at all going to react with dilute acids, so there will be no chemical
Okay.
reactions for them. Okay,
Yeah.
the other parts which are there, okay, that we are going